In this video, we're going to look at another application of linear equations, and we're going to do specifically a mixture problem. In this problem, we have a coffee shop, which is charging $9 per pound for French roast coffee, and then $8 per pound for Sumatran coffee. How much of each type of coffee should be used if we wish to make a 20-pound blend that sells for a cost of $8.30 per pound? So as we work through these problems, we always want to read them first, and then we want to determine what our variables are going to be. And the variables are determined by looking at the question part. And this says how much of each type of coffee. All right, so we have two types of coffee. We want to know the pounds for the French roast. And I'm going to indicate that by using the letter F for French roast. And then we also need to know the pounds of Sumatran. So I'll indicate Sumatran with a lowercase s. So those are my two variables. I have two unknowns. We want to find out how much of the French roast F and how much of the Sumatran S. So since we have two variables, that means we need to be able to develop two equations. So we want to blend or mix the French roast and the Sumatran to make this new blend. And how much of the new blend are we going to want all together? We want a 20-pound blend. So one thing we know is when we're all said and done, that French roast plus the Sumatran needs to equal a total of 20 pounds, right? We also have information about the cost. Now, we know the cost of the French roast is 9, and we know the cost of the Sumatran is 8. We know we want this total cost to be $8.30 per pound. So we'll say that 9 times the French roast plus 8 times the Sumatran. And what is that going to equal, right? Is that going to just equal $8.30? Well, let's think about our units here. For example, F represents pounds, plus S represents pounds. So pounds plus pounds equals 20 pounds. So all of my units were the same. What did I do with my units here? So 9 is actually $9 per pound times F, which is pounds. So we're actually ending up with a dollar amount. Same thing with the 8, right? That is $8 per pound times S quantity of pounds. Again, we have dollars. So dollars plus dollars is going to equal dollars. What number is going to go over here on the right side of my equation? Well, it's $8.30 per pound. So we'll say 8.3. For how many pounds total? The total amount of pounds when we add F and S is going to be 20. So you'll see there, I've got 8.30, that is dollars per pound times 20 pounds. I worked it out like this to really make you think about the units because I often find that's where the mistake in setting this up comes in, is leaving that total poundage out. So take a second, pause, make sure you understand how I've created this system of two equations. At this point, we can solve the system pretty easily. We'll go ahead and use the substitution method. I will rearrange my top equation, F plus S equals 20. I can rewrite that and say F equals 20. And when I moved that S over, that would be minus S. So I'll take that and plug that into my other equation. 9, F is equal to 20 minus S, plus 8 times S equals 8.3 times 20 is 166. At this point, we now have one equation. I took the green and purple and combined them together. I have one equation with only one variable. The only variable we have is s. So now I'm just going to distribute. I have 180 minus 9s plus 8s equals 166. I can combine like terms on the left side. So I have 180 negative 9s plus 8s is minus s equals 166. I'll subtract 180 from both sides of the equation, and that gives me that negative s equals negative 14. Dividing by a negative on both sides, we get s equals 14. So what does s mean? S means pounds of Sumatran. So we need 14 pounds of Sumatran. Well then, how many pounds will we need of the French roast? 20 minus the 14, F equals 20 minus 14. We're going to get that F equals 6. So that means 6 pounds of my French roast. And that is how you solve a mixture problem. Again, when you are working through these word problems, it's really, really important for you to think about your units as you set up your equations. And then you just need to always remember that for however many variables you determine you need, how much of each type of coffee, how many pounds of our 2 types of coffee, that meant 2 variables. So for however many variables you are using, that means you will need to create that same number of equations. So 2 variables means you need to create 2 equations. And then when you're thinking about those equations, think about the units that you have. As always, let me know if you have any questions, but there is a application of systems of linear equations dealing with a mixture problem.